Dear students, welcome to my new channel RX by Jahid. In this video lecture, we'll study on HVAC system. So let's start. HVAC is an acronym referring to heating, ventilation, and air conditioning, three closely related fundamental functions found in homes, office, and other building structure. It's the technology of indoor environmental comfort. This system design is a major subdiscipline of mechanical engineering based on the principles of thermodynamics, fluid mechanics, and heat transfer. HVAC system is an integral part of our pharmaceutical manufacturing area. It's called lungs of pharmaceutical manufacturing. So why lungs? First of all, you need to learn what is the basic function of lung in our body. Usually, lungs take the air into our body, and we take the air. Then our lungs and trachea filters those air, and we take fresh air into our blood. Okay, and HVAC system also do the same to pharmaceutical manufacturing area because uh, our pharmaceutical manufacturing area requires a very fresh and clean air, and using the HVAC system, we clean those air. So that's why this HVAC system is also called lungs of our pharmaceutical manufacturing area. So why HVAC gets special attention for product protection, personnel protection, cross-contamination prevention, and environmental control. So there are some primary regulators for HVAC system in pharmaceutical area. For example, FDA 21 Code of Federal Regulation Part 211 regards the HVAC system in any manufacturing area. Then European Medicine Agency of European Union um, includes this for as a requirement in manufacturing. Then WHO includes GMP guidelines, which require this HVAC system. And another one is PICS, that is Pharmaceutical Inspection Cooperation Scheme. These also require HVAC system. So what is CGMP? It is set of rules, regulations, guidelines for construction of manufacturing facilities, manufacturing process, and cleanliness. So what is the basic rule of HVAC system? So control airborne particles, dust, and microorganisms through air filtration using high efficiency particulate air filters, pre-filters, and fine filters. Maintain room pressure, maintain humidity by cooling below dew point or by using desiccant humidifier, maintain space temperature. So the basic role of HVAC system is to control the airborne particle in any manufacturing area, then control the temperature, control the humidity, control the pressure. So there are three functions of HVAC, that is heating, ventilation, and air conditioning. So why heating? Why heating is significant in maintaining adequate room temperature, especially during colder weather condition. There are two classifications of heating, local and central. The latter is more commonly used because it's more economical. Furnace or boiler, heat pump, radiator make up the heating system. Then another function of HVAC is ventilation. V means ventilation. On the other hand, is associated with air movement. There are many types of ventilation, but they all function similarly. Ventilation is necessary to control carbon dioxide to go out and oxygen to get in, making sure that people are inhaling fresh air. Stagnant air causes the spreading of sickness, usually airborne and allergies, but it's also essential to maintain efficient ventilation system, especially in the 80s. Insufficient ventilation usually promote the growth of bacteria and fungi because of high humidity. It will also decrease the effectiveness of rafter and roof sheathing insulation because of water vapor condensation. So ventilation is also important for maintaining fresh air in manufacturing area. And the last one is AC, air conditioning. It controls the heat as well as ventilation. They often come in different sizes. Most air conditioners have large air ducts, so it's better to check out the building first to see if they can be installed. It's necessary, though, that the air ducts are properly cleaned. Pathogens thrive in dirty air ducts. Return air grills are also vulnerable to chemical, microbiological, and radiological elements. Thus, HVAC return air grill height should be that it is not accessible but visible for any observation. Actually, in HVAC system, we control the temperature and humidity very efficiently in a controlled manner. The temperature control is required primarily to offer a comfortable working environment for operator. So it should be in the range of 19 to 23 degrees Celsius. Lower temperature are normally selected in manufacturing environment where special poorly ventilating garments are used, as in clean room. Within the manufacturing environment, certain areas of manufacturing facility like those where autoclaved and heat and dry heat sterilization tunnel and oven are located provide higher heat load to the system. Humidity control in most cases is also a comfort requirement. However, the manufacturing process also demands specific relative humidity level. Comfort level are 45 to 55 degree relative humidity range, where manufacturing process requirement can vary widely. Some products are manufactured in controlled environment with a relative humidity range of only 15 to 30%. This is the case with many freeze-dried products. So airborne contamination control is also another function of HVAC system. The HVAC system should be designed to provide control over the airborne viable and non-viable particles so as to satisfy the level of control specified for the environment. To prevent airborne contaminants from entering the clean or aseptic area, all air supplied must be filtered. The level and type of filtration depend on the level of cleanliness required. The main method for airborne contamination control in production is air filtration. So now, as we have discussed, that contamination is a very critical factor for maintaining proper air in HVAC system area or clean room area or manufacturing area. So we need to learn what is particulate. Airborne particles are solids suspended in the air. The size of contaminants and particles are usually described in microns. So there are two sorts of particulates, including external and internal sources. So external sources are outside air introduced into the room. This is typically the largest source of external particulates. Infiltration through doors, window, and other penetration through room barrier. So how it can be prevented? By air filtration, room pressurization, and sealing of all penetration into the space. So room pressurization means we have to keep high pressure in the controlled area. So in case of internal sources, people in the clean area, people are potentially the largest source of internally generated particulates. Surface shedding, material ingress, process equipment, manufacturing processes are also responsible for internal sources. So how it can be prevented? Design airflow path to shield human from surrounding, use of air shower, using hard surfaced non-porous materials such as polyvinyl panel, epoxy painted wall or glass board ceiling, then proper gowning procedure, headwear, etc. So there are two types of particles. One is viable and another is non-viable. So viable are the particles that contains one or more living microorganism. It's generated from personal working inside classified area. So this comes from human, and non-viable particles comes from any manufacturing site or tablet or capsule, etc. So non-viable particle are particles that does not contain living organism but act as transportation of viable particle, which is generated through system, process, and movement. So now let's dive into the basic components of HVAC system. So there are several components of HVAC system like air conditioner, filter, air handling unit, fans, blowers, furnace, circulatory pump, cooling tower, damper, ducts, humidifier, dehumidifier, controlling and alarm, economizer, valve, monitoring devices, etc. So let's see the components. This is air conditioner. Ducts look like that. Filters. Economizer is a machine which makes our system very economic. Okay, that reduces the energy losses. Air handling unit. This is called the heart of our HVAC system. Humidifier provides humidity condition or moisture condition in our area. This is a fan which provide the air into the front side. Dehumidifier. This reduces the humidity. Furnace or heating unit. Valve, circulatory pump, control system. This is the cooling tower. monitoring and alarm device, that is the control system, and the damper. So this is the overall uh, overview of our manufacturing area, which contains HVAC system. We can see here that this is our manufacturing area. Our manufacturing area is collecting the air, the fresh air. So how fresh air is coming? The fresh air is coming from directly air handling unit. Okay. So what is the function of air handling unit? This is filtering the air. It can be outside air or it can be the manufacturing area air. Whatever the air is, the air handling unit will filter those air and will supply this into our manufacturing area. However, there are some other components like valve, dehumidifier, humidifier, circulatory pump, furnace, fans, cooling tower, air conditioner, etc. So these are all the components of HVAC system. Here is the this is the room of our manufacturing area. Here you can see seats, you can see the drying compression machine, etc. Okay, this is the manufacturing area, but you can see that how larger the HVAC system is. Okay, so it's a vast term which includes all of the components, and every component has its own function and mechanism. Okay, so let's discuss this one by one. First of all, air conditioner. Air conditioner is a home appliance system or mechanism designed to dehumidify and extract heat from the air. The cooling is done using a simple refrigeration cycle. So two type of refrigerator are used: vapor compression and adsorption. We'll discuss this in a separate chapter. Air filter, we can easily understand that is a device composed of fibrous material which removes solid particulates such as dust, pollen, mold, and bacteria from the air. Blower or fan. Air handlers typically employ a large squirrel cage blower driven by AC induction electric motor to move the air. The blower may operate at a single speed, offer a variety of set speeds, or be driven by variable frequency drive to allow a wide range of airflow rates. Furnace or boiler. That's why this system is called heating ventilation. The heating is due to the furnace system because it will ultimately raise the temperature. Okay. A boiler is a closed vessel in which water or other fluid is heated. The heated or vaporized fluid exits the boiler for use in various processes or heating applications. It's usually made of alloy steel. In case of furnace, the air is heated there. Damper. So we see this instrument sometimes in our classroom. It controls the flow of air in particular room. Okay, a damper is a valve or plate that stop or regulate the flow of air inside a duct, chimney, or air handler. A damper may be used to cut off central air conditioning to an unused room or to regulate it from room by room temperature and climate control. Its operation can be manual or automatic. Ducts. Ducts are used to deliver and remove air that include supply air, return air, and exhausted air. Air ducts are one of the method of ensuring acceptable indoor air quality as well as thermal comfort. A duct system is often called ductwork. Economizer, as the name suggests, to make overall system very economic. Okay, so economizer are mechanical devices intended to reduce energy consumption or to perform another useful function like preheating a fluid. In simple terms, an economizer is a heat exchanger. Economizer help reduce air conditioning cost by bringing cool outdoor air into buildings. They are commonly seen on rooftop air handler. Economizer consists of damper, linkages, actuators, and controllers. So this is overall a photograph of economizer. We can see that it collects the outside cold air, and make the system very efficient. Air handling unit. This is the core of HVAC system. It's a device used to condition and circulate air as part of heating, ventilation, and air conditioning system. So it includes the supply and return fans, the heating and cooling coils, the humidifier, some stages of air filtration, a series of control devices that regulates the performance of every component within the units. So this is overall structure of air handling unit. You can see the cooling coil, reheating coil, the filter, preheat coil, mixing section, outdoor air, and the supply air duct. So this is a air handling unit. It is also shown here. So what are the pros and cons of AHU? The main advantages include circulate the air by which air becomes cleaned, regulation of temperature helps to reduce the noise level. However, it has some disadvantages also. For example, cleaning and maintenance of air handling unit is very difficult and it is very costly. So good place for growth of bacteria and fungus. Okay. HU are very costly and this can be quite loud. Okay. So these are overall pros and cons of HU. Now, as we have already seen that how HVAC system is working. Suppose we have a room in our manufacturing room where drying, mixing, filling, sealing of parenterals, or drying, mixing, lubrication, granulation of solid doses from our carrying out. This is our manufacturing room, and we have already seen that our air handling unit is providing air through the ducts. Okay, so just consider you are sitting in the room and air is supplied into your room by air handling unit or by or the HVAC system. So there are two main types of HVAC system. One is called once through air and another is recirculated air. So as the name suggests, once through air means if air comes into your room, then the exhausted air will be sent back to the air, the atmosphere. Okay, they will not be recirculated. But in case of recirculated air, what will happen? We'll use the air as a recirculated portion. I think you have already understood what I'm going to say. So this one will be recirculated, but if the exhausted air is not reused, then it would be once through air. So we can easily understand that this is infiltration. Air can be entered in your room by different ways. That is exfiltration. For example, if you open the door of clean room area, then what will happen? Some of the air would get out from your area. That is exfiltration. In the meantime, some of the air will come into your room. Okay. So this is the overall sources of air entry and air pass into your room. So let's see what are the advantages of once through HVAC system. We can see here that 100% fresh air and it can handle hazardous materials. Okay, because you are getting the fresh air from the atmosphere and it's not the recirculated air. So that's why it's very fresh air. And however, there are a number of disadvantages of this system. For example, these are expensive to operate, especially when cooling or heating, because you are just using the outside air. Okay, it will be very costly. Then filter loading very high. As you know, you're taking the outside air from every now and then. So what is happening? The frequent replacement of filter may be needed. And lastly, potential need for dust collection and clean out is needed. However, uh, once through HVAC system can be applied in different areas like lab with hoods, potential hazards, bulk API plants, oral solid doses from unit, and where high potential of cross contamination is a potential factor. So in that places we can use the once through HVAC system. However, our most commonly used HVAC system is recirculated air system because that is very efficient. We can see here that uh, we are again using the return air. So what is the purpose of using return air, or what advantages do we get by using the return air? You see, the air which we are using in that room is very conditioned. That is, its temperature is very conditioned, its pressure is conditioned, its humidity is conditioned, its particulate level is very conditioned. For this reason, the air that is entering in your room by supply duct, then this air is very important for you and very valuable. Okay, and to send it back to into atmosphere would not be very cost effective. Okay, so if we can reuse this conditioned air, then it would ultimately decrease our overall cost and energy for filtering those air. Okay, so that's why return air or recirculated air HVAC system is commonly used in our manufacturing area. So we can see here infiltration and exfiltration. Air is coming and air is going out by different reasons, but we are using the return air. So you can easily understand that what would be the advantage. The advantages would be the disadvantages of once through, that is usually less air filter loading. Okay, opportunity for better air filtration because air is conditioned already. Less challenge to HVAC, for example, better control of parameters like temperature, relative humidity, airborne particles. Okay, less away air. And however, it has some disadvantages. The disadvantages would be as the advantages of once through. Okay, you can see the return air ductwork routing to air handling unit may complicate above ceiling. Chances of cross contamination require adequate supply of air filtration. Okay, so these are the disadvantages. You can see the advantages of the once through has become the disadvantages for recirculated HVAC system. However, it is most commonly used. You can see that in the sterile manufacturing area, you can use this in oral solid dosage form like capsule or tablet. Okay, you can use this. Then in final bulk API, usually with dedicated air handler for each room, you can use this system. So recirculated HVAC system is very common and very efficient and very useful HVAC system for our manufacturing area. So we can see here, if you uh, want to give a new pharma company, then how you would design your HVAC system. Okay, so this is step-by-step procedure. First of all, you have to have a layout design and building construction, that where you will place your manufacturing area, where you will place your HVAC system, because every unit doesn't require this HVAC system. Okay, for example, warehouse area doesn't need this HVAC system. For example, a pharmaceutical manufacturing area has also a engineering department. This engineering department doesn't require HVAC system. But if we say about parental area, obviously this parental area is very critical area because life-saving medications, parenterals, injectables are prepared in that area, and that's why in that area HVAC system is required. So first of all, building construction, then defining the HVAC requirement. Okay, cleanliness level, room temperature, relative humidity, you have to specify this. Then cooling load and airflow compilation, then selection of airflow pattern, then pressurization of room is required, then air handling system is set up, then a duct system design and construction is done. After that, selection, location and mounting of filtration system, defumigation requirement is needed, commissioning, performance qualification and validation is required, that whatever you have already designed and constructed, what would be the qualification of these. Okay, and what would be the validation pattern of this. You have to do this at the very latest stage, testing and validation, and finally the documentation. Okay, these are the step-by-step procedure for HVAC system design. Now let's see the building construction, how we would construct this HVAC system. The internal particulate generation always is the focus of any clean room design. The internal generation consists of those from building equipment such as wall, floor, ceiling, equipment, most importantly from operators. So what should be the quality of material used in construction? All material used in construction should be non-chipping and cleanable. Wall and floor finishes should not shed particulates and should provide self-cleaning surfaces. All exposed surfaces should be smooth and unbroken, otherwise this can generate dust. Okay, so no uncleanable recess and minimum of projecting ledges, shelves, cupboards and equipment. Sharp corners should be avoided between floor, walls and ceiling because this can have a generation of bacteria within that. There should be no use of wooden or plywood material in production area because this can generate dust. Okay, false ceiling and the tile joints in the floor should be completely sealed, and the sink and drains should be prohibited in grade class 100 areas. All doors in the sterile area should have airtight construction. Special gaskets should be provided on the door frame and drop sills provided at the bottom of the door. Epoxy painting should be carried out in these areas. So you have already seen that actually uh, what would be our quality of doors, windows, floors, ceilings. Okay. So in our next lecture, we'll start with HEPA filter and HVAC system. So that's all from my topic. If you have any confusion and any question, please let me know in the comment section. Thank you.